going to look at some bar graphs and other kinds of graphs in this lesson. And we're going to start by using these two graphs here on this page to answer a few questions. So I'll come back to these once we look at the questions. So we're going to see what information is shown in these graphs, how are the graphs similar, and what are some advantages and disadvantages of using each graph. So I'm going to talk through these three questions while looking at the graphs. So first of all, the information that's shown, you can see by the title, these both talk about Central Indiana Ivy Tech degree pursuits. And you can see the AS, AS, TC, CTAA, and these are also shown down here. So they're all the same. Now, the graphs are similar in that they have the same information. So the information that is shown in these graphs also is the answer to number 2, which they're similar because they show the same information. However, they don't necessarily show it the same way. I think it's easier in this graph, the bar graph, to really see the difference between the two degrees. And yeah, you can say in the first one that, well, this section is so much bigger. Well, it is, but I think it looks a lot bigger when you compare the size of the bar graphs versus the size in the pie graph. So an advantage might be just in the visual representation of what it shows. You could come up with a gajillion advantages and disadvantages of each graph. It's really what you want to highlight as to what makes it maybe a better or a worse graph. Okay, so we are going to move on then and looking at unemployment rates. Nope, I lied, that's later. This is population and percentage. So employment status. Non-institutional population by educational attainment is what we're looking at, even though this up here says status. These graphs are all put together. But anyway, so you can see that this is the population, which is this information. So you can see it says in thousands on this side, which is good because it says in thousands here. So when we say less than a high school diploma is 24,175, that's really in thousands. You need to add another 3 zeros onto that. So just so that you're aware, make sure you're paying attention to the details of tables and of graphs, right? Because sometimes it's easy to kind of just get caught up in looking at the raw data they give you and not recognizing that it's actually, add 3 more zeros. So it does say use the second row of data from the table to create a bar graph. So we're going to use the second row, this information here, to actually create our bar graph. So when I do that, less than high school diploma is 11%. Then we have high school is 29%. Okay, I'm going to go through and complete the bar graph without necessarily showing. Okay, so I made my horrible bar graph based off of this data here, and you can kind of see. Now, when you compare them, dang it, I don't have a copy of the two, but when you compare these two graphs, you can see low, high, low, low, right? Look at the pattern. It's the same pattern for each one. So when you're comparing these graphs, they have the same pattern. So they kind of show the same data. The only difference is this graph gives you the percentages. This graph gives you the actual raw data. Now, why use bars of equal widths? Now we're going to use, whenever you make a bar graph, whether it's a regular bar graph, a histogram, a Pareto chart, it doesn't matter. Any type of bar graph needs to use bars of equal widths. And we do that to avoid bias. I mean, you can imagine, if we're looking at this bar graph, if I make this bar a lot fatter, your eye is drawn to that because it's a different look, a different style. So if you make one graph, and if I made maybe this graph super skinny, why? What's the significance? It just draws up so many more questions and adds a little bit of bias of why are you doing that? Why are you making these things different? So when you use bars of equal width, you're making it more uniform. It makes a little bit more sense when you're talking about how to display data accurately. Now, in number 3, is there a big difference in the number of people with some college and those with an associate's degree? And then how can we quantify this? Well, if we're talking about some college, right? So some college is here, and then associate's degree is here. So we're looking at these two values. So we're talking about 35,326 compared to 20,937. Now, the first question is, what do you consider big? Do you consider big, if we subtract these, we get 14,389. There's the quantified difference. There are 14,389 more people with some college than with an associate's degree. Is that a big difference? Well, actually, I think this is in thousands. We should add 3 more zeros. I don't know what you consider big. So, I don't know. It's all relative. But there is a difference, and that difference is the 14,389,000 in terms of this data that's given. Okay, let's move on to a different graphic. And we have the civilian labor force. So this is total labor force per area based off degree, and the number of people who are unemployed in thousands for that particular area. So we then have the unemployment rate. Well, remember the rate, these are actually in terms of percents. Now, if we want to complete the table, we have to consider how is the unemployment rate calculated. So if you think about, let's just kind of work on less than high school diploma. If you think about this, if we want to find the unemployment rate, we're going to take the unemployed over the total. So if we took 873 divided by 10,971, and I don't have to add the zeros because they're both in thousands. Because if I would put 1,000 over 1,000, based off our mathematics, right, they cancel out. So when I divide these two numbers, I get like 0.079, which is approximately 8%. So that's what we're going to do for bachelor's degrees and advanced degrees. We are going to take the number of unemployed. So for this one, we'll take the number of unemployed divided by the total, and we get our unemployment rate of 2.8. And then for the advanced degree, we take 429 divided by 19,449, and when we do that, we end up with 2.2%. So even if you have an advanced degree, you do have a possibility of being unemployed. All right, so we completed that table. Now we're going to use this table to do a few more things. So number 4, how many high school graduates were unemployed? Well, here's the high school graduates here, and it comes from the table. You can see exactly high school graduates unemployed is here. So 1,920,000. Don't forget that this table is in thousands, so we have to add either 3 zeros or the word thousand after it. What was the unemployment rate for high school graduates? Which again, okay, we're going here. If you look at the table, it comes out to be 5.4%. So if you're a high school graduate, you have a 5.4% basically chance of being unemployed. All right, now if we're going to compare these two graphs, why do the bars follow different patterns? We're given the same information. I mean, this is raw data, how many are unemployed. This is the percentage of people that are employed. So why are they different? Well, if you think about it, there's a different number in each of these categories. So we are dividing by a different number. Oops. And if you divide each thing by a different, even though the numerator is going to be different, if we were dividing everything by the same denominator, it would give us the same pattern. But because we're using different denominators for each one of these, that's why we have the different pattern. There are less people with advanced degrees, and therefore you're going to divide by a smaller number, you're going to get a different number, right? So it all depends on what you're dividing by. And you can also tell, you know, we have the biggest number here. This is also big, but it's relative. It's what you're dividing. Since all of these numbers are different, that's what creates the different pattern in our graphs. Now, we are going to complete the last two bars. We've already talked about the unemployment rate and how it's calculated. We took the unemployed divided by the total, and we got 2.8 and 2.2. So when you the thousands, this is the raw data, 900 would put us up here, and then 429 would put us down here for this one. And for the unemployment rate, we're at 2.8 and then 2.2. So you can see that even when you add those two, the second graph continues to decrease as you go down, whereas this one is, you know, a little bit more of a curvature because you're dividing by the different numbers. Is it reasonable to talk about the skewness of the distribution of these graphs? And you may say, well, yeah, no, whatever, but here's what it comes down to. Remember that skewness compares really the mean and the median of the data. And to compare the mean and the median of the data, you have to have, numerical data that you can calculate. We cannot add together less than a high school plus some college plus associates plus bachelor's plus advanced and get a number. This is categorical data. So really, because you are dealing with categorical data, you can't find the skewness. I mean, you can still, if you were explaining the shape, you could say, well, it's got the shape of skewed right. That's the shape of it. But you can't really use that as a definition or as a concrete way to describe it, because skewness implies a mathematical measurement, and with categorical data we can't have that mathematical measurement. So you got to make sure that you are paying attention to the data that you have. Okay, pros and cons of these graphs, or why you might choose one over the other. Well, let's just go ahead and look at this sheet. If you're, well, we'll look at this one because we completed it. If you're trying to convince somebody that they really should get an advanced degree, you might want to use the second one. Look at your unemployment rate. You have a way better chance of being unemployed if you don't have any kind of degree at all. And as you get a higher degree, right, high school, some college, associates, bachelor's, advanced, the more degrees, the more education you have, the less chance you have of being unemployed. Or you can look at this one and say, I'm better off dropping out of high school compared to graduating from high school because my unemployment goes up. Well, that looks like it on the graph, but there's more than 3 times as many people with high school graduates than less than a high school diploma. So that the raw data doesn't take into account how many people are in that particular category. So that's why the rate is maybe better, because it does take into account how many people are in each category. So, it kind of depends what you want to use and what you're trying to say. General conclusions from this, again, remember we had 2.8 and 2.2. Oops, 2.2 is a little bit higher than that. General conclusion, and I think I've already said this, it looks like the more education you have, the less chance you have of being unemployed. So that's a general conclusion. Is that true? I don't know, but that's what the graph shows. So we'll kind of go with that. And that's kind of your introduction to bar graphs.